So how many of you are aware of what software observability is? Do you guys write code, daily ship to production? You do? Alright. You're lying, man. You don't. Yeah. You sell observability. So let's cover why do we need software observability. And this is a term that I've seen being floated around for almost a decade. And I don't think many of us, even I didn't until yesterday, understand the need of software observability. And it's important to go down and understand why do we really need this thing. The simple answer is to build great software products. Now it seems counterintuitive because a big jump on why do I need observability to build something good. And for that, let's talk about two of the greatest products that I've known. Facebook is one of the products that I really admire for what they've done. I don't have a Facebook account, but I still admire the product. And there is an Apple iPhone. Do we agree these are probably one of the most iconic products that we have seen in a fairly long time? And I think this is where our problem started. Because two of the biggest evangelists who built the best products ruined the software industry. One of them said, "Real artists ship." It's a very famous quote by Steve Jobs, and who says, if you are building a great product, you have to keep shipping. And one of them, the other one said, "Move fast and break things." And I think that was the point of our industry when we started shipping software like crazy, like frenzy. I do remember there was this company, there's Etsy, who really popularized this opinion that we ship almost 18 times every day, which effectively means they were shipping a build every hour. Now, one of the important things to understand is when you don't change something, it doesn't break. Look at the old software, like the one that is running out there just by lying around. We got a Windows installation. Anybody use Windows still? Like Windows 98 maybe? Like if it's installed in a computer, it doesn't break. We say that XP was the best software that was ever written because we never updated it and just kept on running forever. So if you don't change something, it doesn't break. Or if you change it, it will break. And that's where the need originates. Now change is of two kinds. One is a change that I make to the system and I'm the cause behind it. The other change is an unknown change, which is the impact. I ship a software that's a change I'm trying to introduce in a system. Something has changed without my knowledge is an impact. Now one of them is good, the one of them is bad. I don't have to tell you which one's good. What is the realm of a change? There are two kinds of changes. And I'm going to harp about change all the time here. Behavior has changed. What effectively means is that you expect a system to do something, but it's not doing it anymore. And that's change. Or my expectation has changed from a system. Either I've given up on a system or I expect it to do higher, but one of the two has changed. Either a behavior changes or an expectation changes. What are the types of changes that a system goes through is also very important to understand. The first change is the software. We keep tinkering. We just spoke, keep shipping. You introduce a new software. The underlying software itself has changed. Another change is the traffic has changed. I have a website out there and my users have started consuming it in a different way. My service goes viral. Until yesterday, I was expecting 1 million traffic. Now I expect 2 million traffic. The usage is increasing. The traffic has changed. The user behavior has changed. That's a change. The underlying system has changed. Until yesterday, we used to run on 18 machines. Now we run on 20 machines. Now this may have an adverse impact. All of these kinds of changes, if you try to build a mental model here, can result in an unexpected scenario because you're changing something constantly. You're tinkering with the system. Or the data itself has changed. Until yesterday, you used to receive data in JSON format. Somebody has started sending in XML as well. Nobody sends XML, but for the sake of an argument, we can assume that. Or the volume of data has changed. Or the variety has changed. The velocity has changed. There could be another thing. Nothing has changed other than the fact that somebody has tinkered a configuration. I love these changes though, because they're the hardest one to find. And the perennially changing thing, which is the time has changed. For 8 o'clock, the system behaves differently on a Saturday. Today is Friday, or today is Friday. Yeah. So tomorrow the system may be expected to work differently. A lot of it is going to change. And all of these are realms of a change under which the software is constantly going through. The products that you build are constantly going through these changes. And your job is to stay on top of it. Because change is inevitable. You're going to constantly keep changing things. It will constantly keep improving, or for the good, where you send a change deliberately, or it will change outside of your knowledge, which is not good anymore. Sometimes we push a change. We don't expect the expected to happen, right? And this was one of the CrowdStrike things that happened recently, where somebody pushed an update and they weren't expecting that a lot will change after that. The eternal chase at the end of the day is where you're trying to detect one simple thing, which is you're detecting the change that you did not wish to see. And that is where the pursuit of software observability starts. I call this a Schrodinger's change, like a change that you haven't observed. Did it really happen or did it not happen? So you need observability to constantly keep an eye on it. Is this change really happening? And this establishes the first time that we say that we need observability. Now, how is it done? We'll get to that. But it really establishes to observe a change in a system, which could be on any one of those parameters which are happening underneath. You constantly need to keep looking at a system. To constantly say, okay, measure, has X change, has Y change, has a software version change, has my system performance change, has my traffic change, has a configuration change, has any data change. You're constantly trying to measure from point A to point B to understand what has changed underneath. Because the change could literally be anywhere in a system. And that is why this pursuit of observability is endless. It's not a destination, it's a lifestyle. Actually, that's a good one. Yeah. Software observability is a lifestyle. You know what? A watch pot never boils. We say that statement all the time. So if you keep watching it, I don't think you will observe a change. So you need to look away and hope that a system tells you that something has changed. Because all of you software developers cannot keep looking at logs all the time, metrics all the time, graphs all the time. How many of them will you look at? So you need a system out there which tells you, hey, something has changed on the parameters that you defined the change for. Do people like fish and chips here? Are you guys Londoners or outside of London? All right. I ran into this yesterday and I learned the most topic of my life, which is you will not be offered a change. You must bring your own change. The hawker told me that because he only accepted cash. But who is you here? We keep saying you, but who is this you? I say, hey, you got to observe your system. Hey, you got to do better software observability. Hey, you better wake up. Now, you. So who is this you? It's important to understand who is this you here. You could be anybody in the organization. It's not just limited to a developer. This you could be an SRE. This you could be a product manager. This you should be a customer success person. This you could be a salesperson as well and could be a CEO as well. The realm of observability does not limit itself to one particular role of an organization. It goes all the way. Why would a developer need to observe? Because they observe because they are detecting changes so that they can debug their system faster. Why do SREs care for change? Because they want to do system monitoring better. They want to understand what has changed in the system. Why do product people change that? Product people change that because they want to detect a change in product performance. Is my daily active user count the same as monthly active user count? Is the same as yesterday, as the last month or the last quarter? It's a constant change that we need to stay on top of to make better decisions. Or CS. Is my renewal in threat because of a change in a customer expectation or my change in system behavior or sales or a CEO matter for that? This makes it critical. And here's a ladder that we go on. All of us, we start with basic monitoring. This is we're starting to observe change. We go with basic monitoring. From basic monitoring, once we are done understanding how the system is operating, we go to faster debugging. Once we have done with these, all the elemental tools in place, which gives us better answer for debugging faster, we start moving towards another change analysis, which is impact analysis. We'll cover all of this. Then there are proactive actions. And when all of this is in place, we hope for a system where there's an improved uptime, which is the end pursuit that we all sell towards, right? Everybody who's out there selling you a system observability stack, including me and that guy, is giving you this promise of improved nines out there. But a 9 is the last step of it. These are the stages that you have to go through to make sure everything is in place so that you can have all the 9s in place. And that's what makes observability critical. That's the ROI of it. So you need an observability system so that when a change happens, how to answer these questions. The first question, what is the impact? Who got impacted with this? Which user got impacted with this? Is there a workaround for this current situation that I'm in? Are others users being impacted as well, as much as this user that I see or this customer that I see? Has this happened before? How was it solved the last time if it happened? Is there segmentation, which means that this could only be happening in one region but not the other region, on one server but not the other server? These are important questions. Every time you detect a change in your system and it alerts you, you have to answer these questions. Or, who needs to be informed about it? This is the communication realm of it. The change doesn't stop. You have to communicate the change as well. Are there other dependencies that depend on the system? Are they aware of the downgrade that is happening in my system? Going further, where else is this being used? What alerts did not trigger? This is very late into the scenario. When the change has happened, it has impacted the users, and now we ask ourselves this question: why did we not get alerted about it? Was there a pattern in any of this that happened? And last of it is this line: does it need a code fix? This is very important here, because most of our tooling, if you look out there, everybody who's out there and says that, look, observability is done using better logs, metrics, and traces, because you got to find out where the problem is in a line of code. But in all of this, if we go back again, that is the last question we ask, not the first one. But if you look at it, our tooling today is only designed as debugging first. All of our tooling is designed to ask the least relevant question and not the most relevant questions. And the most relevant questions are understanding how do we mitigate this situation, who else is impacted, and these require higher order tooling. Now if you take a guess at it, what each of these roles are trying to look at when they approach an observability system, what do they want to answer? Of course, this is the most obvious one. Developers want to answer, what line of code do I need to change? And the whole tooling, the entire gamut is designed towards them that, hey, use tracing because it will tell you which service dependency is down. This is the line of code that is a problem. You can probably fix this. You can add more servers to it or infrastructure to it, problem solved. But what about the other personas here? There must be a system administrator out there who's saying, is there a change in server or database performance? That's a question that needs to be answered. And that doesn't get answered through tracing, but some other tooling. There may be an engineering manager who's trying to ask, are 99% of my requests under 300 milliseconds? Because they understand not every request is worth it. They are willing to sacrifice, a few hundreds of requests. Imagine at Google scale. Would they really care about every request that goes slow? They say, it's peanuts of money for us. It will cost me more to actually deploy engineers to find out where the line of code is. So might as well go with some of them and say 99% of my requests are fine. And you need tooling which can help you answer this question, which can help you reach this point. There may be product people out there who will be asking, are 99% of my users happy? Now this is a pivotal shift that is happening in a question here. The engineering side of it will care for, are 99% of my requests happy? But the product never looks at that. Product says, are 99% of my users happy? Now this pivotal shift requires different data, different tooling. Is there a change in my daily active user count? There could be customer success teams out there as well who will be asking, is there a change in my customer experience? Or here's a new one, like completely different, which most observability systems will not even talk about. There's a guy called Mark, logs in from 10.0.0.1, but today logs in through 10.0.0.2. This is a change. This is a change that very well needs to be flagged. We may say, hey, this falls under security, but this actually falls under change which will result in something breaking somewhere. Or the board meeting, which goes about saying that our customer expectation met, is there a change in sales in Q2? These are the questions that we must be able to answer to leverage the best value of investment that we make towards software observability. It's a journey, not a destination. Starting with basic monitoring again, which tells you what is broken, or going about saying faster debugging, why is it broken? Moving into higher order questions, who is impacted by it, or proactive actions. When can I get alerted faster? Ultimately, if all of it works well, hoping to have an improved uptime. There's a famous quote that goes here, the measure of intelligence is the ability to change. I'm going to rearrange this a little. And I say intelligence is the ability to measure change. Yeah, I'm sure the guy would have done the same if he was alive today. And now when you look about going with an observability system and you say that, okay, fine, I'm convinced. But by the way, are you guys convinced now that you need an observability system, or do I need to start this entire presentation again? No? Alright, cool. I want to hear a yes, please. Yeah, cool. Now when you are convinced that there's an observability system that you need out there, you may build this or you may buy this. Or you could do both of it as well. Now, you may assemble your own furniture using Grafana, Elasticsearch, some metrics database, some tracing system, and you are a firm believer of DIY, you say, I'm going to do this at home. Great. Or you say, I don't have time for this. Maybe you are the more rational one and you have better things to do in life, and you say, just going to buy it. Cool. Or you simply say, I have spare engineers with me. I don't know what to do with them. They have their own career growth paths to manage. I'll do both of build and buy. Decisions are taken that way. No matter what you do, whichever side you are in, there are certain expectations that you have from your observability system, which goes through the passage of storing it, querying it, and visualizing it. And each one of those steps is going to require a lot of work, which will be either going down to improving your integrations, your data sources, the storage layer solving for. I've added more of these so that you get little threatened with the amount of work that you have to do so that you don't go and actually build this yourself. But yeah, eventually that's the gamut of work under there. All of this is trying to improve your software observability maturity. Remember the ladder. You do all of this so that you climb the ladder eventually. There are certain pains. When you go about buying this observability software out there, how many of you like Datadog? You? Do you work at Datadog? Oh, okay, all right. Has anybody else used Datadog? Everybody? Have you paid Datadog something? All right. Do you still got kidneys left inside you? Okay. So it's expensive buying it, right? Now, one of the challenges when you go about buying a system like this is the total cost of ownership. Your total cost of ownership is constantly compounding. It's increasing. Every time you have to do something more, they almost punish you and penalize you for scaling. As you earn more, they want to earn more than you earn. Now, there's also challenges of high cardinality, which I will not dwell into, but I'm more than happy to chat about this outside, is as the amount of server, infrastructure, etc. increases, the ability to do things actually diminish. It's counterproductive, but it just works so far. Buying also has another problem, and this is a very important one because there's a lot of lock-in and no flexibility, which means that if you got your data in those silos or these vendors, these proprietary people, you cannot get it out to build anything. You cannot pull that data out into your IPython notebook to say, I'm going to do forecasting analysis or I'm going to do performance analysis over a past year, because the data is just not available to you. It's sitting somewhere, but they won't give it to you. Now, you may say, okay, buying is a bad choice. Let me build it. Let me tell you, building is the worst choice. When you build it, you guys have used Elasticsearch at home, right? Like you must have used it, you must have assembled these databases somewhere in your team, or if you're not doing it, your platform team will be doing it somewhere. When you're expecting an homegrown tool chain to improve your reliability case, what you're effectively doing is you're hiring your internal developers as product managers of observability, and they're doing my job. You're expecting them to tell you, hey, here is where you're wasting data. Here is what you're not observing. These are the signals that you're not tracking. You're not doing CI/CD monitoring. All of this somebody has to tell you to improve your observability maturity, and that's not happening. You can only do what you know. You don't know what you don't know. Another challenge that I've seen when people actually build it is cross-team adoption. You always run into this challenge of, hey, I built these nice dashboards, but my teams are actually not using this. How do I make them use it? It's not a single pane of glass. Your logs are somewhere, your metrics are somewhere, your traces are somewhere, and you're constantly using your mouse to scrape that data in real time when problems happen to identify where the root cause is. It costs a lot of time. You will spend at least 9 months to 1 year building this in-house. And everybody understands the pain of what slow dashboards are. And you're constantly throwing more infrastructure at it. I don't want to cover more, but these are the pains of building and buying all. Now, so you need something which solves it. And this is where I'll slide in a vendor pitch. This is what we do. So at CoroLogix, this is where I work at. You can use us, come talk to us. We are a booth outside. We give you the benefit of both building and buying. Not pains of both, benefits of both. Yeah, like to believe so. Now, once this is in place, I want you to understand one time, and I think this is the most important thing that I say, that why do we need software observability? You're shipping software out there as people who are in the software industry. You're touching people's lives on everyday basis. You're changing their lives every moment, whether you're on Instagram, whether you're Twitter, whether you are Gmail, you're touching their lives. If you're not on top of the changes that are happening in your system, you really don't know which way you're changing their moments. And it's important to know that, because that's what eventually defines the success of a great product versus products which had potential but could not deliver. That's me. I work at CoroLogix.com. We are outside. We're a booth. You want to understand the bones of software observability, come talk to us. We believe we are the experts at it. And as promised, we are the painkiller. What else would you like to know more? Questions and answers are open. I've left them stunned.
Maybe you already said, but I forgot it. So you mentioned about building and buying, but there is another options to use open source alternatives for this?
That's less effectively building it, right? Because I'm not saying when I say build, you build the databases from scratch. Build a solution. You could have used AWS Managed Kafka, right? This is buying a solution versus hosting your own Kafka, which is building a solution. So you're not writing Kafka, but you're actually using open source to build the service yourself. Not build the technology behind it, but build the service that your company will use. So does that answer what effectively building would be? Right. Do you want to build one? Like when you say your version of build or my version of build? Your version of build, so you want to build it from scratch? We are hiring. Come to work with us. So, but I'll advise not to build. Like it's a painful journey. Yeah. You like pain? Oh, morbid thoughts.
Maybe one more. Everybody wants to go home, right?
You don't go home for 3 minutes. Yeah. Better ask a question and leave. So. See, there you go. That's how you invite people. All right, next questions. 5 pounds each. Yeah. Next one, not you.
In the initial part of the slides, you were talking about how to answer questions at different levels from different roles up to the upper management, the board, right? But I guess it wouldn't be easy, or I wonder who would be responsible for collecting the metrics that are able to answer different stages of the question. If I, for example, work in the platform team and I am able to collect certain metrics, but I might not have access to client satisfaction or other type of metrics. I guess it would be like a general effort from many different places to be able to aggregate all this data, right?
Absolutely. So usually I classify this as a 4-stage problem. The reason I land on this slide is because every question, so once you have data, and so like a snowball, like it's like a waterfall model, you realize I have data, what questions can I ask? And then epiphany hits you, which is like a outage hits you, and then you realize I don't have the data to answer the questions that I need today. And then you go back to the original state, you say, okay, I'll start instrumenting this, I'll start emitting this data, and then I see if I can answer this question. So it's a trial and error, the whole effort, to go from having no data and having no answerability or no questions to having some data and asking the relevant questions until the next one happens where you realize I don't have the data for this. So it's a trial and error that you go through. It's a hit and miss because now the CEO may come up and say that, hey, I need to understand how we are doing sales. But the platform team says that, but we don't have the metrics for this. Then the platform team goes to the product team and says that, hey, can you get us some engineering bandwidth? Because the CEO is asking me to ask engineers to build this. Engineers say, cool, we'll add it to a sprint. 3 weeks later, you'll get it. Now, this is a whole cycle behind it. And effectively, what I'm describing is what we call as maturity, because this is maturity. Now, imagine if on day one, an auditor came to you and said, all right, you are a financial company. You are going to require X of these metrics, which we have seen from experience, to say, you better have these questions be answered, and they improve your posture because they are making you aware of what you don't know today. And this is best done by providers out there and platforms out there because they can make you more aware and educated about what you lack today or what your data lacks today. The person who liked pain, building it themselves, I'm sorry. So, yeah, or they build it themselves, it's a more trial and error. Yeah. Does that kind of answer? Okay. Yeah.
Hey, so thanks for the talk. So In the slide before this one, I think you mentioned, sorry, the one before, there's a slide with various stakeholders,
Right.
leading from like starting from developers all the way up to management
Yes.
and CS. Now, what you tend to find is that as developers, we tend to prefer a certain kind of stack, right? Like an OGTM stack, and you have like this ecosystem around common tools and systems, right? But then if you look at other more business-oriented platforms, you have stuff like ClickSense, you have Looker, and slightly different looking views of data that may be derived from the underlying data that developers add into their applications. Assuming that CoroLogix has basically have implemented a good abstractions to help provide value at different levels of the stack, do you feel that there's any inertia from various stakeholders in using anything other than what they're currently used to?
Yes, 100%. Because you're making somebody go against their natural habit. The only way you can make somebody go against their natural habit of doing something is by offering them a part of their daily workflow or lifestyle that they are currently not able to perform. If you're using Gmail, and if I was to sell you Superhuman, you will only buy it if I give you something extra which you are supposed to do manually today, or you feel the pain of it. Now, that's a generic answer I'm giving for any product. In our case, which is why we are constantly building these use case scenarios to say that, look, if you were trying to do session analysis, and I'm just making this up, I'd rather do this at the booth outside, but for the general audience, if you were to do effective infrastructure monitoring. Now, this is a use case, because you could have done this by just using metrics, etc. But here is a value add, which is going to save you a toil or hours of understanding what is the relevant infrastructure, what should I measure, which CloudWatch source or which Kubernetes source do I need to get these metrics from, and this is toil. So if I take away that toil from you, you will be more inclined to try out a newer product. And same goes for product analytics as well. Now, if I say Mixpanel gives an answer to most of the product questions, but is only as smart as your events are, and they're only as shallow as the front-end client is. It has no correlation or has no knowledge of how the backend performed. Now, this is a curse and a goodness both. Because good, because you don't have to rely on engineering, you can do this yourself. But bad, because when something really hits you, you don't have the data to back it up. Now, if I can give you that value, you'll be more inclined to try this out. Gives you an answer?
Yeah, I think that makes sense, yeah. Effectively solve problems at different levels that would increase the probability of actually getting value from it, and hopefully that would lead to adoption of the tool, right?
That's correct, yes.
I guess I have a second question.
So £5 for this.
£5, okay. So, like, obviously, as developers, we have to add various, emit various logs or traces or whatever, or events that can be leveraged to create these dashboards and effectively observability into the system. You can say the holy grail for at least looking at the performance of your of the product as observed by the end user is what we want, right? So, as developers, we might look at the usual system metrics, right? CPU, memory usage, throughput, etc. But of course, as we move up the ladder and the fidelity of the metrics that we're getting, there needs to be cross-stakeholder involvement in how and what we admit, right? So that we can actually get this value. Is there anything provided by CoroLogix to actually make that easier?
Yes, that was almost a talk in itself, your question, but yeah. If I was to summarize this, and for the general audience, and tell me if I'm hearing this correctly, a lot of observability is desired to be towards what users are experiencing. What is the common thread that brings all of these commitments and agreements and understanding together to say this is really what we are chasing to deliver? Is that a rough?
Yeah, pretty much, yeah.
Okay, all right. The industrial answer to that is service level objectives, service health monitoring, service cataloging, because service is the single binding thread that exists in an organization, which nobody can define what a service is, but everybody understands that we are a part of the service. If you ask somebody, hey, what is a service, they would not know. But you say, are you a part of the service? They say, yeah, we are or we are not. And these are standard answers to it. Start with the service catalog, do service health monitoring, set service level objectives, because they abide to the end delivery towards the user experience. And yes, we have first class support for that. That's the industrial answer, and that is what we do as well. And so you should be like good to go. You should just try it out. Yeah. There's a man up there at the right corner of the back, and he will give you a good for this. Yeah, the one waving. Yes. Yeah. Any more questions? Oh, that's Chris.
I want to. Who's got a question? Anyone got a question? I would like to ask a question.
Me?
Yeah.
Oh, okay.
What is, in your opinion, right now, is that there are a lot of trends going on in observability and a lot of interesting sort of dynamics happening. Do you think there are any sort of big prevailing trends that are coming? And if you say AI, I may throw the microphone at you. Other than that,
You had to bring that word now. There is, and somebody was asking me this the other day, so I don't know where, but it's a very recent conversation. If you look at when this observability market exploded, was towards the advent of everything going mobile. This was year 2012 and 2013. I'm assuming everybody is old enough to remember that era. Everything became mobile at that time, like in terms of how we consume. We used to be all PC bound, but then we became mobile bound. And computation just exploded. We weren't speaking at the same scale. There were two companies and two trends that came out. One was compute became ephemeral. Compute became almost taken for granted. You could scale out fabrics of compute beyond that time. AWS made a lot of money. And you could spawn servers because now you have millions of users who are on the go trying to use your application. But when that happened, when compute explodes, you require observability because compute results in wastage, compute results in downtimes, compute results in lack of coordination, all the changes. Interestingly, the era that we sit in right now, there is another compute which is exploding. If you look around, graphic cards, it's exploding right now. NVIDIA is making a lot of money. Everything that we want to do is massively compounding in its ability to compute. We say that AI models are getting cheaper because our compute is getting cheaper, is becoming more commoditized. As there's a direct trend line here. When our compute exploded, the need for observability exploded, and we had to build tooling which could tame that. The same thing is happening right now. It's no longer mobile compute which is exploding. Now it is your AI compute which is exploding. But the tool chain for that is not yet holistically developed. And that's the trend in which we're going towards. Does that give a mental model, Chris? Yeah. So, yeah, expect the next wave to be about addressing this. Can I go home now?